Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to talk about how to graph the secant and cosecant functions with transformations. Okay, so we've already looked at sine and cosine. Now we're going to look at secant and cosecant, which in essence, we're just going to, if you watch the parent graph video, we're going to graph sine and cosine, and then we're going to turn them into secant and cosecant. All right, so let's get started on making these graphs, and we'll go from there. Okay, so let's talk first about the general form for these two. So we have y equals a cosecant b, quantity x minus c plus d, and then y equals a secant b, quantity x minus c plus d. So these have the same meanings, a, b, c, and d, as they did the other day when we did sine and cosine. So A is your amplitude, so to speak. Okay. B is the period changer. C would be the phase shift, but we don't look for it using our method. And D moves the graph is the vertical shift. Graph moves up and down. Okay. Now, for both secant and cosecant, those graphs both started. So to figure out your new start place, you're going to take b, quantity x minus c, set it equal to 0. Okay. The new period is, again, the parent period divided by b. The parent period for both cosecant and secant is 2 pi. Okay, same as sine and cosine, because basically we're going to graph sine and cosine, and then we're just going to create the cosecant and secant graphs like we did when we did the parent graphs. All right, and then the new stop point for that cycle is going to be the new start plus the new period. That'll tell us where to stop that cycle, where the cycle ends. Okay, so basically, all we're really going to do is the following. If I give you an equation that says y equals a cosecant b x minus c plus d, we're going to say, nope, I'm going to do this as sine and then turn it into cosecant. And if I had one that said y equals a secant b, quantity x minus c plus d, I'm going to say, nope, I'm going to do cosine and then turn it into secant when I'm done. You got to remember to turn it into these graphs, though. Don't leave it as sine and cosine. All right, let's get started. You basically already know how to do all of this. Okay, you really do. So we're going to graph y equals cosecant pi x over 2. So, nope, the reciprocal of secant is sine. So instead of doing graphing cosecant, I'm going to graph sine and turn it into cosecant. So here we go. I need to find a, b, and d. A is 1. That's the number before the trig function. B is the number that's multiplied by x, which in this case is pi over 2. D is the number that's added or subtracted at the end. That's 0. So this is the same thing that would move the graph up and down. That's what we're talking about for D, the thing that would move the graph up and down. All right, so now the new start. To figure out my new start place, it's going to be, I'm going to take pi x over 2, set it equal to 0, and solve for x. So I'm going to multiply by 2 over pi on both sides to get x alone. So x is 0. So that's my new start. All right, same as the normal parent. I'm going to start at x equals 0. The new period is going to be, I am going to take the parent period, which is 2 pi for sine, and divide by pi over 2. So that's really 2 pi divided by pi over 2, which is 2 pi times 2 over pi. Pi's knock each other out. I get 4. So the new period is 4. 4 units, no pi involved. Okay. And then the new stop place, I'm going to take 0, where my new start is, and add the new period, which is 4. So I'm going to stop now at x equals 4. All right, that's it. That's all you need. So now we're going to go ahead and graph it. So I'm starting on 0. I'm stopping at 4. I need the midpoint between 0 and 4. Halfway between is 2. Halfway between 0 and 2 is 1. Halfway between 2 and 4 is 3. Amplitude is 1 unit high. So from 0, I'm going up 1 unit, and then 1 unit low down to -1. Okay, right now I'm going to graph sine. I'm going to do it as a dashed graph, and then I'll turn it into cosecant as soon as I'm done. So sine, the pattern is middle, high, middle, low, middle. So I'm going to make it dashed, my graph here. That's the sine graph, but I don't want to graph sine. I want to graph cosecant. So to graph cosecant, anywhere sine is 0 is a vertical asymptote because cosecant is 1 over 0. So there's an asymptote there, there's an asymptote there on cosecant, and there's an asymptote there. All right. Now, these points, the high point and the low point, the maximum and the min, are shared between the two graphs. They're on both graphs. And now I'm going to take this piece of the sine graph and flip it up. So if I do that, I make a parabola that opens up. We'll try that again. Make a parabola that opens up. And then down here, I have this point in common. I flip this one down. It makes for me a parabola that opens down. So when you graph cosecant and secant, you actually don't touch any of this area between -1 and 1. Okay, the graph is not contained in there at all where the sine was, the graph, other than the high point and the low point, which are in common. And now if I erase the sine graph, oops, this is the graph of the cosecant. It's done. So basically what we do is we literally go and graph the reciprocal and then turn it into the one we want. All right? All right, we'll try again. This one is much more complicated. So we have y equals -2 cosecant 4 quantity x minus pi over 2 plus 1. All right. Got to find A, B, and D. A is 2. The amplitude has to be a positive number, but the negative means you're going to reflect it, right? You're going to flip it over the x-axis, okay? Just like our regular transformations always did. This means reflect it over the x-axis. All right, so I'm going to write 2 for the amplitude and then reflect so that I remember to flip it over, okay? B is the number multiplied by x. It happens to be out here. It's 4. D is the number that's hanging off the end. It's 1. All right, let's talk about the new start. So this graph is now going to start when 4 quantity x minus pi over 2 is equal to 0. Got to solve this for x. I'm going to divide the 4 out. I have x minus pi over 2 equals 0. X equals pi over 2. This is where I'm going to start now. I'm starting on pi over 2. Okay. The new period is going to be the parent period. Well, this is cosecant, so we're graphing sine. So that's going to be 2 pi over 4. So 2 pi over 4 is pi over 2. So my period is pi over 2 as well. This graph will stop. I'm going to take the new start, which is pi over 2, and add the new period, pi over 2, to pi over 2, which is pi. It stops on pi. Okay. All right. That should be enough to go ahead and make the graph. So here we go. This graph starts at pi over 2. It stops at pi. All right. So now I need to find the middle of pi over 2 and pi. So I could, if you know your unit circle, you could do it that way, or you could literally add them. So I need 2. That's 2 pi over 2. That's 3 pi over 2. And then I got to take half of it because I want the middle. That's 3 pi over 4. So the middle is 3 pi over 4. Now I need the middle of pi over 2 and 3 pi over 4, so I got to do some adding again. Let's see, we got pi over 2 plus 3 pi over 4. So that's going to be 2 pi over 4 plus 3 pi over 4. That's 5 pi over 4, but I got to do half of it because I want the middle. So that's 5 pi over 8. 5 pi over 8. And then I got to do the same thing here with 3 pi over 4 and pi. So 3 pi over 4 plus 4 pi over 4, 7 pi over 4, but I got to do half of it, 7 pi over 8. Okay, so far so good. All right, now I got some other things to deal with as well. This is the start here at pi over 2. We're not starting on 0. All right, my A amplitude is 2, but I'm flipping it over. Okay, so that's going to change my pattern. And then D is 1. So D is literally going to take the midline or the x-axis and move it up one space. I got to do that now. So here's my new x-axis. It's one space up. Okay, now from here, I can do the amplitude. So if I'm one space up and I'm going 2 up from there, that's 3. And then I'm going 2 down from 1, that's -1. Okay, so I'm graphing cosecant, so I want to put the sign on here. Sign is, the pattern is middle, high, middle, low, middle. But this is reflected. So I'm going to start with the middle. Then I'm going to go low, middle, high, middle. And I'm going to graph it dashed. Okay, that's my sine graph. But I don't want sine. I want to know what cosecant looks like. So I'm going to have to do that. All right. So I got to turn this into cosecant. So where the graph's in the middle, there are asymptotes. One there, one there, one there. And then the low point's in common. Parabola that opens down. And then the high point's in common. Parabola that opens up. And if you want to, you can erase the side. And you have it. There's your graph. That's what you're looking for. That's the correct answer. Okay. All right. Let's keep going. All right, let's try one with secant. Let's try y equals 4 secant 3x. Okay, I don't want to graph secant. Let's graph cosine. That's easier. So A is 4, B is 3, D is 0. Nothing being added or subtracted at the end. All right, the new start. I need to take 3x and set it equal to 0. If I solve for x, I just get 0. So we start on x equals 0 again. The new period is going to be the parent period. So the parent period for cosine is 2 pi divided by 3. 2 pi over 3. So the stop place is going to be 0, where I'm starting from, plus 2 pi over 3. I'm stopping at 2 pi over 3. Okay. So that's enough. Let's go ahead and make our coordinate plane here. We're starting on 0. We're stopping at 2 pi over 3. And now we got to find the middle of 0 and 2 pi over 3. So that's going to be 1/2 of 0 plus 2 pi over 3. That's 2 pi over 6, which is pi over 3. Okay. The middle between 0 and pi over 3 is 1/2 of 0 plus pi over 3. So that's pi over 6. And then the middle of pi over 3 and 2 pi over 3. So that's 1/2 of, let's see, we got 3 pi over 3, which is pi over 2. Final answer. Okay. We're not moving the x-axis or the midline up and down. The amplitude is 4, so we're going 4 units high from there. 4 units low from there. We're graphing cosine, then we're going to turn it into secant. So cosine starts high, middle, low, middle, high. So we'll graph it dashed. There it is. Now, when you have zeros on cosine is where you have asymptotes on secant. So there's one there. There's another one there. And these high points and low points, the low point and the high points are shared in common. This high point here comes up toward the asymptote. Okay, basically it takes this piece and kind of flips it up. This one in the middle makes a parabola that opens down, and then the other side also gets flipped up and looks like that. That's the other half of this parabola that's over here. Okay, there's your answer. It's done. So if you know how to graph cosine, you know how to graph secant. All right, let's try this last one here. We got A, we got B, we got D. A is 1. There's a 1 in front of the secant. You don't see it. B, the number multiplied by x is 1, and D is -2. So the new start is going to be, I'm going to take x plus pi over 4, set it to 0. So I get -pi/4. And then I have the new period. That's going to be 2 pi over b. B is 1, though, so the period doesn't change. The period's still 2 pi. And then I'm going to stop at -pi/4 plus 2 pi. 2 pi in 4s is 8 pi/4. So that's 7 pi/4. That's where the graph is going to stop, this cycle. All right, so we got, let's see. I have points on both sides this time. All right, so we got -pi/4 over there. Then we have 7 pi/4 over here. All right, so we have, we've got to find the middle. So half of -pi/4 plus 7 pi/4, that's half of 6 pi/4, which is 6 pi/8. And half of 6 pi/8, oh no, we did half. That's 6 pi/8. That's 3 pi/4. So halfway through, 3 pi/4. So we'll say it's right about there, 3 pi/4. Then we got -pi/4, half of -pi/4 plus 3 pi/4. That's half of 2 pi/4, which is pi/4. So that's going to be pi/4. Let me move this this 3 pi/4 over a little. Oops, that's the highlighter. Move this 3 pi/4 over here a little bit. 3 pi/4. Then we got pi/4. And then between 3 pi/4 and 7 pi/4, that's going to be 5 pi/4, right? That's the middle between the two. That makes sense. Okay. You can figure it out, too, if you didn't know. We'll move my -pi/4 over here a little bit. All right. Let's see what else we have to deal with. We have D is -2. So the midline, the x-axis, is moving 2 units down here to -2. So that's my new middle. A is 1. So I got to go up 1 from there and then down 1 from the middle. Okay, and now here we go. So we're starting off high for cosine. Oh, high is at -1, though. High, then middle, low, middle, high. Sorry, it's getting kind of crowded in here. All right. So now here's my middle line right here. So the points on there are going to be my asymptotes. There's an asymptote there and there. Draw right through there. We have a high point here, and then this part of my cosine graph gets flipped up. So we're going to have a piece of a parabola. Then we have a low point here, and down. And then from here, we're going to flip up. And there's the graph. You don't need the cosine graph in the middle. That's the graph of secant. Okay? And that's it. That's all there is to it. You basically graph sine and cosine again, turn them into secant and cosecant, which we've already done. All right? And as always, thanks for clicking.